Mr. Bob's Railroad Workbench, where we talk about math, science, history, and trains, and do it all with some very fun activities. Hello, I'm Bob Lutzenberger, Mr. Bob, Education Director for the National Railroad Museum. If you're watching us today on Facebook Live and want to type in a question, feel free to do so. We'll answer those after the segment. If you would like to just type in and let us know who you are and where you're watching from, we'd love to hear from you. Also, make sure that you like the National Railroad Museum's Facebook site. Well, today here on Mr. Bob's Railroad Workbench, we need to talk about some more geometric shapes. And today we're going to do it in 3 dimensions. Previously here at the Workbench, we had talked about various geometric shapes in 2 dimensions. And we discovered shapes like the rectangle, where you have 2 parallel sides, 2 more parallel sides, and 4 equal angles in the corners. We talked previously about the square, where all sides are of an equal length. The angles in the corners are equal as well. We also talked about the circle, a continuous loop, no ends, no beginning, and if you pass a line through the center point on a circle, any point on the edge, that line will be of equal distance, called the diameter. We also talked about the basic 2-dimensional shape, the triangle, with 3 sides, 3 angles, not always necessarily equal to each other. Now, in 2 dimensions, we were looking at our shapes based on height and width. But we know that things around us exist in 3 dimensions. We can pick up an object. We can see that there is height and width and depth to an object when we look at it. And when we look at plans like we are for a steam locomotive, in 2 dimensions we can see where our various geometric shapes in 2D come into play. The tender shaped like a rectangle, the roof of the cab a square, a circle for the wheels, and a triangle for that cow catcher out front. But what happens if we extrude those shapes and bring them into 3 dimensions? You'll notice the circle that forms the front of the boiler. Well, if we extrude that circle, we get something called a cylinder that makes up the boiler. Well, what do you know? On steam locomotives, there actually are cylinders that are part of the running gear. And there again, we have a circle at the beginning, and we have extruded that to become a 3D shape called a cylinder. Let's take a look at our train here and figure out a little bit more about those 3D shapes. When we look at our big box car here, we see that in 3 dimensions, yes, we have a rectangle on the side and another rectangle that makes up the roof. Now, in 3 dimensions, we now call these faces. So a rectangular object that has been extruded becomes a prism, and we have different faces that make up that object. In 3D terms, we also need to add in the word edges. Where those faces come together forms an edge. So we have, and that is called a vertex. Where the lines of those different faces meet, that is called a vertex, or in plural, vertices. And on a boxcar, we have many vertices where those corners of those faces come together. So let's look down our train a little more. We extruded a rectangle and got a prism. If we extrude a circle, like we did on our steam locomotive on the screen a moment ago, we end up with a cylinder. How about a triangle? Well, on our hopper car here, there is a triangle that makes up the floor that is slanted down. When we extrude that, we get a prism as well. So far, we've been talking about shapes that have relatively flat faces. Yes, our cylinder is curved, but on the end it does have a flat face. What if we have an object, say like our orange, that is completely round, a sphere, as if we took a circle and spun it? It becomes a sphere. Now here we have no vertices, we have no flat faces, we just have one curved face. A sphere, what also can happen to a circle. There's another type of three-dimensional shape that we should think about as well, and we can see it in our carrot here. If we had a triangle and we spun that around, what would we end up with? Well, it would be a cone shape. So, 2 dimensions, we're looking at just height and width. When we go to 3 dimensions, we add depth. We talk about faces, whether flat or curved. We talk about edges, where the faces meet. And we talk about vertices, the corners on those objects. Squares become cubes, rectangles become prisms, circles can become cylinders or spheres, triangles can become prisms or cone shapes. So a little bit more about three-dimensional geometric shapes here on Mr. Bob's Railroad Workbench. You know what? The National Railroad Museum inspires lifelong learning by providing educational opportunities through the preservation of railroad objects, engaging exhibits, and innovative programs. As a nonprofit educational institution, we are supported by both public and private donations and our museum members. If you would like more information on how to support the National Railroad Museum, visit our website, nationalrrmuseum.org. You can also find information there on how to become a museum member. And as always, thank you so much for your continued support. Hey, I'm Mr. Bob. Thanks for visiting Mr. Bob's Railroad Workbench today, and we hope to see you here again real soon.